So yeah, let's talk about decentralized AI. I'm Yogesh Darji, co-founder at Lumino AI. We are building a decentralized training protocol. Our mission is to build world's most advanced AI infrastructure company powered by blockchain and crypto. We do that by building two things. First is building a set of developer and SDK tools, and second is by building a decentralized protocol for compute resources. Our team at Lumino brings over a decade of combined experience both in AI and blockchain technologies. So let's talk about the current landscape. The new law of AI compute. As you can see, the amount of compute required since 2012 has been doubling every 3.4 months. For perspective, Moore's law has a 2-year doubling period time. So that's basically 300,000x increase every single month. And Moore's law is only like 7x increase. According to a research paper by OpenAI, they mentioned that there are 3 things that are important to the advance of AI. First is algorithmic innovation, second is data, and then the third is the amount of compute needed to do the AI training. Algorithmic innovation and data are difficult to track, but computation required to train a model is usually quantifiable. That's at least one metric that can be leveraged to basically track the progress in the space. We can also see that in the number of machine learning papers that have been published on archive, you can see that even that has exceeded the Moore's law. Approximately 100 new papers are getting published every single day on archive. That's about 35,000 papers per year. And this is only 70% of the total papers that have been published. Remaining 30% are published on journals and conferences. So let's talk about the difference between model training and inference. So training is basically an education phase where a model learns from the massive amounts of data sets. It is intensive, time-consuming, and takes up large amount of resources. During this training phase, you would have to give a model like large amount of compute resources, and this can take weeks or sometimes months to train an entire model, and sometimes more than that for really large, complex models. Inference is something when you put all of that training done to the real work. So what you do is you take that model, deploy it to a smaller server, and then you basically feed new sets of data where it will do predictions and pattern recognitions. So also another thing to note here is that training requires 100x more compute than inference. But here's the kicker. It's not only compute intensive, compute is also 100 times more expensive than inference, which means a lot of investments needs to be made in training large language models. Let's look at the need for growing compute power. As you can see in this graph, when we begin from the left, the smaller models like BERT, they utilize modest amount of compute. But as you move towards right, the amount of compute needed just grows over time. As you can see, GPT-3, 175 billion requires over 3,000 petaflops per second days, which basically means that you're running like thousands of GPUs non-stop for months. So what is the challenge with centralized training? As you can see that most of these AI resources are concentrated with handful of few large big tech companies like OpenAI, Meta, Google, Lambda Labs dominate the space. This graph shows that last year, Meta and Microsoft alone had basically placed an order of like 300,000 H100s for themselves, making little to fewer H100s available for smaller players. You can also see the amount of spend on these large language models by larger companies. Llama 3 itself, the spend was $720 million. And as you can see, like GPT, Gemini, and there are like other models which are not on this graph, have spent significant amount of resources to train these models. So how can decentralizing these model training can help? So decentralized training solves few problems. First is it allows you to store the proof of training on-chain, which means all the training that has been done by a node operator can be stored on-chain, which is verifiable. So there is an audit trail, so someone can just go back and verify that the model was actually trained correctly. The reason we need that is because model training is non-deterministic. So it's hard to verify whether the model was trained correctly or not on a node provider sitting somewhere in the world. Another thing that to do is using verifiable proofs. It allows you to ensure the data integrity of the model training and the results itself. Third is it solves the problem of trust. By storing all this information on-chain, it allows a user to basically trust that the compute provider would have actually would have actually trained their AI model. When you look at larger companies like OpenAI and AWS, there is already an inbuilt trust. They generally are not incentivized to misuse your data set because their reputation is at stake, and there are also regulatory compliance. But in a decentralized network, that doesn't exist. And also with big tech, it's really hard to go and verify that they did not actually tamper with your data. In a decentralized network, you take control of your own data, and then you can actually go and verify that the models have been trained correctly without any tamper. So here, we basically show that the GPU marketplaces, the revenue for just the spend on H100 orders has been increasing over time, and this will hit $600 billion by 2030. So let's talk about how we can leverage older, underutilized GPUs in a decentralized network. So here, you can see that NVIDIA A100s, 40 GB, let's cap it at 100% performance with 0% cost savings. Moving on to A40, which has about 90% performance and gives you a 10% cost savings. And V100 gives you 83% performance with a 20% cost savings. Now, as you go down, you look at RTX A6000. This is a very interesting comparison. With only 24% drop in performance, you're getting 40% cost savings, which means the older, cheaper GPUs can still perform better and can actually be made to use to do all this large language model training. Some of you would ask, what about privacy? This has been a major concern in training models in a decentralized network. For customers who are willing to pay a premium for the compute resources, there are several techniques that can be used. You can use encryption techniques where you can encrypt the data, and then whatever party has a decryption key will be able to decrypt, train the model, and then send back the original results. We can also use something like multi-party computation, where you basically shard the models and the data sets on a different compute providers so that no single party has access to all the data. Things like functional encryption also helps encrypting the data where the computation only happens on the encrypted part of the data sets. We can also use differential privacy, which basically where you can use different techniques such as redacting the parts of the data set, such as PII information. You can add noise to the data, or what you could do is you could just take a small set of data from a customer and then actually add, basically create a synthetic data sets out of that original data set. So that way, no compute provider can actually see the real data, and you can still keep data private from these different compute providers. All right, so yeah, talking about future of AI training at Lumino, our mission is to basically keep the AI training as open and accessible to everyone. By building this set of world-class developer tools, we are making this decentralized training available to large number of users at significantly lower cost. We've spoken to customers firsthand and have seen them struggle. Even being an enterprise customer on AWS and Azure, they haven't been able to secure these large-end GPUs. By being part of our decentralized network, they get access to all these GPUs at significantly lower cost. Yeah, if you'd like to keep up to date with all the latest development that we are doing at Lumino, please join our waitlist. Here is our Twitter and our website. Thank you so much.